Hi friends, welcome back to my channel. Still on Power Machines N5. Today we are doing throttling of steam. My name is Tsepo. Please subscribe to my channel to make sure you receive more videos like this, and click that notification button so that you will be notified every time I post a new video. So today's topic, throttling of steam. Throttling of steam, a steam is said to be throttled when it is passed through a small orifice under pressure. So P1 will always be greater than P2, which is PP. PA will always be greater than PB. And then we throttle steam to improve its quality. Now we will start with wet steam, and throttle it, try to produce from it superheated steam. Superheated steam. And then the enthalpy for wet steam, H wet, which is at A, will be equals to H soup, the steam that we will produce. And then we know that this one is at the pressure, which is pressure P, and then this one will be H wet, is at pressure A. And then we have an instrument called a separating, separating calorimeter. A separating calorimeter is used when now we have a steam that is too wet to be throttled. And then we have, for throttling, we are using now a throttling calorimeter. A throttling calorimeter. So to make sure that we, out of these two, we get good results every time, it's better for us to combine them. So we combine these two calorimeters, which is the separator and then the throttler itself. So this is the separator and then the throttler. And this is called the main line. It's the main. It's where steam it's traveling before it reaches the separator and then the throttler, so that it can be throttled. Now in every stage, the steam will have a different dryness fraction, which in the dryness fraction in the main, it's x3, and then the dryness fraction in the separator is x1. The dryness fraction in the throttler is x2. So now every time you deal with the dryness fractions, try to make sense out of it. The steam here, it's very wet. Here it will be less wet, and here it will be even lesser. It will be even less wet than this one. So you cannot have a steam that is wet, then all of a sudden it goes up. No, it can be wet here, less wet here, and even lesser in the throttler. So our x1 is given by M, which is a big letter M, divided by M, which is a small letter, and then the plus M, which is also a big letter. So the big letter M is the mass of the steam, and then the m, small letter m, is equal to the mass of the water droplets, mass of water. And then our x2, remember we said the enthalpy for wet steam will be equal to the enthalpy for superheated steam. So we know that the enthalpy of wet steam is HF plus X HFG. This is our X2, and then it's equals to superheated steam. And then we can, if we want to get this, we can solve it and say X2 is equals to, H soup minus HF all divided by HFG. This is H soup. We also know that the formula for H soup is given by H soup. It's given by Hg plus Cp, the temperature for superheated, T soup minus saturation temperature. So yeah, that's basically everything we are going to need when we are dealing with throttling of steam. Now we are ready to attempt a question. I have a question here from the textbook. We will try to do it and see how can we apply all this information in the board. Yeah. So the question says, a combined separating and throttling calorimeter was used to determine the dryness fraction of steam flowing through a steam main at a pressure of 900 kilopascal. The pressure and temperature after throttling was 100 kilopascal and 115 degrees Celsius respectively. The mass of steam condensed after throttling was 1.8 kg, and the mass of water collected in the separator was 0.16 kilogram. Estimate the dryness fraction of the steam in the main. Take Cp for superheated steam as 2.09 kg per kg Kelvin. So we were told to refer to figure 7.5. So that's our data, and then we are given a diagram that we were told to refer to. This is the diagram that they gave us. So remember, I gave you a diagram that was saying that okay, so we said our main is x3, the dryness fraction in the main line is x3, and then we said the dryness fraction in the separator is x1, the dryness fraction in the throttler is x2. But in this case we are given a diagram, so that one we just forget about it for now, because we are given a diagram, so we cannot use that, because if we use this, what we know, our answers will be correct but they will be vice versa. So we must use the diagram that they gave us. So we were told to calculate the dryness fraction of the steam at the main, and we know that the dryness fraction of the steam at the main, now we were told that it is x1. We know that it is x1 times the dryness fraction of the steam at the is equals to the dryness fraction of the steam at the separator times the dryness fraction of the steam at the throttler. And then first we can get the dryness fraction at the separator, which is x2, because we know it is given by m plus m, and then we calculate, we put the values 1.8, 0.16 plus 1.8, and I got my answer as 0.918. And then we know that our H wet is equals to our H soup, and this is at 900 kilopascal, and this is at 100 kilopascal. And then what else do we know? So we know that the dryness fraction, this one that we are looking for at the throttle, is found in the enthalpy of wet steam, which is HF plus x3 times HFG is equals to our H soup, which is Hg, that's the enthalpy of gas, and then specific heat capacity, and then in bracket the T soup minus T saturation. And then in this case, for us to make, we can just from all of this make C3 x3 the subject of the formula, then calculate. But I prefer we simplify things and calculate H soup alone. So we calculate H soup separately and say Hg plus Cp T soup minus T, the saturation temperature. And then we said now our Hg, I got it as 2,676 plus the specific heat capacity, I got it as 2.09, and then the T soup, the temperature of superheated steam, I got it as, it's 115 we are given, and then the saturation temperature at 100 degrees, I got it as, sorry, it's at 100 kilopascal, I got it as 99.6, and then my answer I got 270,708.186 kilojoules per kg. And then we can go ahead and substitute this here, and we can just say H soup, because now we know the value of H soup. Then from this we make x3. We will continue here. From this we make x3 the subject of the formula, and we know that these values HF and HFG are the values of the wet steam at 900 kilopascal. And then our x3 is equals to our H soup minus minus HF divided by HFG is equals to our H soup. It's given, we calculated and got that it is 2,708.186 minus HF at 900 kilopascal. I got it as 743, and then our HFG 2030, and then we get our x3. I got 0.968, and then we come, because this is what we were asked to calculate. If you leave your question here, it is incomplete, and then we come and say our x1 is equals to x2 times x3, and then we substitute our x2. Where is our x2? X2, where you? X2, this is our x2. Our x2 is 0.918 times our x3, which is 0.968, and then we calculate, and then I got it as 0.889. So that's everything that they have asked from us, from our side. And then yeah, so if you now have the dryness fractions, you must try to make sense out of them. We know now that it is given like this. So this is the main, and then this is x1, we were told. This is x2, then this is x3. The dryness fraction of x1 is 0.88, meaning that the steam now is 88.9% dry, and then this is at the main, and then at the separator, now our steam we get as it is 0.918. It is 91.8% dry. So you can see from here to here the dryness of the steam is improving, and then our dryness fraction at the throttler we got as 0.968. So you can tell from x1, x2, x3, our steam, the dryness of our steam is improving. So now the steam was 88.9% dry, now it is 91.8% dry, now it is 96.8% dry. So this is how it should be. The dryness of the steam should improve as we are going towards the throttler. If that's not the case, then recheck your answers. Something might be wrong. Something has to be wrong. And then we have another question. Steam in the main at 1500 kilopascal is passed through a combined separating and throttling calorimeter. The steam conditions in the throttling calorimeter are 150 kilopascal, while during the test 500 gram of water was collected in the separator and 8.5 kilogram condensed from the throttling calorimeter. The dryness fraction of the steam in the steam main is 0.9325. Take the specific heat capacity as 2.11 kilojoules per Kelvin for superheated steam. So now our data, as always, we must first write the data, and then now we are told that we are given the information for the steam, the wet steam, and then these are the information for the superheated steam, and then we are given the the dryness fraction at the main. Now, because we are not given any diagram, we use the information as we have learned it. So meaning that x3, x1, x2, this is main, and then this is separator, and then this is throttler. So the question number 1, they say calculate the dryness fraction in the separator, that is x, 1, and then we know that 1.1 x1 is given by m plus m, which is, now we know that the mass of our water is given in grams. We must convert it into kilograms so that we have our masses in the same SI unit, which is 0.5 kilogram. Then now we say 0.5, no, it's 8.5, 0.5 plus 8.5 is equals to, I got my answer as 0.944. And then number 2, they say calculate the dryness fraction in the throttling calorimeter. And then now we know that that's 1.2. We know that x3 is equals to x1 times x2. We have x3, we were given x3, this is our x3, and then we have x1, we just calculated, we are looking for x2, then we make it the subject of the formula and say x3 divided by x1 is equals to, our x3 is 0.93525 all by 0.944, which gives us x2 as our 0.988. And then we are done with question number 2. Question number 3, they say calculate the temperature of the steam. First things first, we know that H wet at 1500 is equals to H soup at 150 kilopascal. And then we know that the temperature that we're looking for, it's in the enthalpy for superheated. So we our H wet is given by Hg plus X, which is our X2 at the throttle, X2 times HFG is equals to Hg plus specific heat capacity T soup, this is what we are looking for, and then minus T saturation, the saturation temperature. And then we have to solve for our T soup and then calculate. First, it will be easy for us if we go ahead and calculate this separately, and then we can now come and add everything. So our H wet, the enthalpy for H wet given by Hg, and at 1500 I got that okay, let's write it first. That's X2 times HFG. Our HF is I got that is 845. My dryness fraction X2 it's 0.988. 0.988 times my HFG at 1500, I got it as 1945, and then my answer I got 2766.66 kilojoules per kg. And then come and put it here. So here we can just substitute this with H wet and then we know that HOH is 276.66 is equal to HG at 150 kilopascal, which I got it as 2693 plus our specific heat capacity, which is 2.11, and then our T soup, what we are looking for, minus our saturation temperature, which I got it as 111.4. Sorry, my space. Yeah, and then we solve for T soup, and then I got my T soup as 143.31 degrees Celsius. So that's basically everything that they've asked for. So let's say you get a question that where you are not given the specific heat capacity. In that case, please, you must use the steam table for superheated. The steam table for superheated, it has pressure and temperature, and then you will it has I think it's temperature and pressure, and then where they meet at, let's take at 1500, and then the temperature will be this. Where they meet, the information that you are looking for will be given there. And then if you are, maybe let's say you are not given the specific heat capacity and you are given temperatures that you cannot find in the superheated steam table, then for your specific heat capacity you will use 2.093 kilojoules per kg. Only if you are given, only if you are not given the specific heat capacity, and then you are given pressure and temperature that are not in the steam table for superheated steam, can you use this. So this is your last option. If you're not given this, first you must start here, and then if you fail here, that's where you can come here. Don't just use this, because if you can get it in the steam table and then you choose to use this one, your answers will be wrong. So that's basically the end of our lesson on throttling of steam power machines N5. Hope this video will be of help to you. Please guys, comment below, tell me what you think about today's lesson. Don't forget to subscribe, share, like this video and share it with others. My name is Tepo, and I will see you on the next lesson that will be on boiler efficiency power machines N5. Ciao.